Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. Today I will try to discuss a very important topic. Mainly it's one kind of our training program on network analysis using Python. So today's session I will discuss about that how we can easily find out the shortest route using Python. I will try to find out all of details step by step. Then I hope you can easily get the idea how we can easily find out the shortest route using Python. I will try to show you that all of those step by step. So first of all, what is network analysis? Network analysis is the study of interconnected system that can be represented as network or graphs. It involves understanding and analyzing the relationship and flow between node and edge. So now what is the nodes? Basically nodes represent entities such as intersecting or buildings or location such as hospital, school or road junction. And is mainly link. It's a link. It represents the connection between the node such as road, pipeline or communication link. Example, roads connecting two intersection or path between buildings. And types of networking analysis such as shortest path analysis. So basically it's find out the most efficient route between the 2 point. Then service area analysis, identify areas accessible with a certain distance or time. Then flow analysis, it's mainly understand the movement pattern across the network. And connectivity analysis, it measure how well nodes are connected. So in this series, I will try to explain all of analysis method. But today's session, I try to discuss about the shortest path analysis, how we can easily find the most efficient route between 2 point. I will try to explain about that. So there's a lot of application in here. So here I mentioned some application to identify network analysis such as transportation and navigation. So we are used at the transportation and navigation to identify for network analysis such as shortest route analysis, finding the quickest way to travel from A point to B point. We also use it. And urban planning, mainly designing efficient road network and accessibility analysis, proximity to hospital or schools. Then logistic, mainly route to optimization for delivery or supply chain management. Disaster management, so mainly identifying evacuation route or allocating resource during emergencies. Then telecommunication analysis, network coverage and connectivity. Environmental monitoring, mainly mapping hydrological network such as river drainage system or analyzing the migration path of animal. So all of those I try to explain step by step, so then I hope we can easily get the idea how we can easily work with that. So now let's check the practical example, mainly how we can easily identify for shortest route network analysis using Python. Step by step, I will try to guide you. You also try to follow this step and you can easily find out the shortest route network. So let's go. So here I just open my Jupyter notebook and after that I try to write the code one by one. So before opening the Jupyter notebook, you can simply install some packages. Okay, some packages, mainly in this case we need this package. One package is called that OS MNX. So this is one kind of package. We also need the another package. It's this package name is that network X, and also need for that matplotlib pyplot. So this package we also need. So just you simply install all of packages OSMNX or network X, as also matplotlib. This type of three packages we need when you work with the network analysis. So these three packages you can simply use the pip and then install these three packages. So in this case I already installed, so it's very easy. Just simply open your terminal and then simply write pip install, then write the package name. So this is the first package, this is the another package, and this is another package. So here I already install all of packages. So now in this case I simply import all of packages one by one. So for that, just use here that import and write the package name osmnx, and I give a short name ox. After that, import the another package, network x package. So just put here the network x as nx. So I put the short name. Further, when I need the package, I simply call the nx. And finally, I import another package. It called that matplotlib dot pyplot, and I put this name as a plt. Okay. So now here I already install all of packages. So now if I just click to the run, you can see this run button. Just run. So it also works. There is no problem. Okay. Because this type of package I already install it in my system. So if you don't install, just simply install and then easily work with that. So after installing this type of package, if you want, you can check the version. Suppose I want to check the version of this package osmnx, this package I want to check the version. So for that, just call the ox, this is my short name, then put here the dot, then put here the version, just try to check the version of ox. So you can find out this is the version 2.0.1. so it means that this package is successfully installed. Okay, so now I can easily work with that. So this is the first step. So I need this three packages osmnx, network kx, and also matplotlib. So just I simply import this type of package, and further I just take the new cell. In this new cell, first of all, I define my location or boundary. So how I can define the location on boundary? So for that, just take a variable. Suppose I put the variable name is the place, and I define my location. Suppose my location I want to focus on, suppose Dhaka metropolitan area. So just I simply write here Dhaka metropolitan area, then put here the district name Dhaka, and it's in Bangladesh. So just I put here that Bangladesh. So just you simply define your place name. So in this case I want to work for the Dhaka metropolitan. So just I put here the Dhaka metropolitan, then put here the district name, and then after that I simply put here the country name. Okay, so now it stored it. I define my place. Okay, so if I just run it, there is no problem. And further I take the new cell. This cell I want to download the street network. Okay, suppose I want to download the street network for my Dhaka metropolitan area. So for that, I just define a variable, suppose g, you can put any name as a variable, and call the ox, okay, mainly osmnx, and put here that a function, this function called the plot graph function. Okay, plot graph function, and I want to create the plot. And before creating the plot, we also put the another step. This step mainly we need to download the data. Okay, we need to download the data street network. Okay, so for downloading the data, just take a variable. Suppose I put the variable suppose g, and further just call this ox dot, I put here that function graph from place. Okay, graph from place, and further I just define my place, and then just define here the network type. So just put here the network type equal, I put here the drive. Okay, so now it download the street network in the drivable road. So just I put here the drive, network type I put the drive mainly drivable road, basically transportation road or road network. So just I simply take a variable and call the ox mainly come from osmnx, and further I simply grab from place and I call my location place, and network type mainly drivable network type, mainly transportation route in Dhaka metropolitan. So just run the code. So now it loading. Okay, so you can see it find out the start symbol, it means that, so now it's loading. So now Dhaka metropolitan all of drivable route is downloaded. Okay, and it is downloaded from the osmnx library. So it's successfully done. So after downloading these things, we try to make a plot and then check the result. So for making the plot of this all of drivable road in the Dhaka metropolitan area, so for that I want to create a figure. So just I put here the fig figure, and then I take a variable, suppose ax equal, I just call the ox dot write the function plot graph. Okay, so after writing the function plot graph, then I simply create the graph for this g. Just I put at the g because z is stored all of drivable road. And further if I just run the code, then check what happened. So we find out this type of road network, but it's not more beautiful. So for that we also add some other argument such as background color. Suppose I define the background color mainly bg and put at the color background color I set white. Okay, so if I run the code again, you can see, so now we find out the background color is white. It look like that, but it not also more good. So I want to add another argument for that. Suppose I want to add here the note color. So just I mention here note color. I define the note color, suppose red. So now just run the code. So now we find out this type of note color as the red, and we also find out that node size we also define in here. Suppose I put here that node size. Suppose I put the node size is the 1. So now let's check what happened. So now we find out this type of map. You can also increase the node size, then we can also find out node size is also increasing. And as color, so you also define, suppose I put here the as color equal, I put here suppose blue color or any color you can mention in here. So we find out this type of as color. Okay, or if you want you can simply put here suppose gray color. So now we find out that Dhaka metropolitan area, we find out this road network and drivable road we can find out in here. So now in here I want to identify for the shortest route. Okay, so basically today's session it is identify for the shortest route, and then how we can easily find the nearest route node in the graph. So find the shortest path between 2 points. So suppose for this point to for this point I want to find out the shortest route. So now how I can find out this type of shortest route? So first of all, for that you need to define your start point and end point. Okay, after that we can easily do it. So suppose I just take a variable. Suppose I put the variable name is that start point, and I define the start point such as suppose latitude and longitude value. Simply define here latitude value I put it suppose 23 23 point suppose 756, and also put at the longitude value suppose 90.463. okay, so this is my start point. Okay, and also define the end point. So just I put here the end point. End point also define the same. Suppose I put the another latitude and longitude value. Suppose 23.821. This is my latitude, and longitude value suppose 90 suppose 365. Okay, so just I define start and end location as a latitude and longitude value I define. So now between these two coordinate I find out the shortest route network I want to find out. So this is my first argument. So now find the nearest node in the graph. So for that we just put here the start node and end node. So let's go. We try to create the nearest node for start and end node. So for that just take a variable start node, and I just call the OX, basically OSMNX, this library. So right here OX dot distance dot nearest nodes. Okay, this is the function distance dot nearest nodes, and then find out it's come from mainly this road network. We already print in the G stored this network, drivable network. So just I put here the G, and then define the start point. So just put here start point and define the value 1, and also put here that start point and define the value for 0. Okay, so just we create the node for that start node, and also create the end node. Same procedure try to apply in here. Okay, just I copy the same line of code, just copy and paste here. So in this case just I simply mention here the end point. So just I copy end point and also end point, and also define it's a end node. Okay, so distance nearest node we can just put here. So now further run the code. So it show a problem, don't match the opening parenthesis. Okay, we have to, yeah, so we have to use the curly bracket and also put the curly bracket again in here. So now let's check again. So now run the code. So now it's okay. So now we create the start node and end node. Okay, we create the start node and end node. So now calculate the shortest path between the start node and end node. Okay, so for calculating the shortest path, we are just use the shortest path function from nx. So just take the new cell, and further I just take a variable, suppose shortest path, and call the nx mainly. I already defined the nx mainly network kx, this function nx. From the nx we are just use a function. This function name is that shortest path. Okay, shortest path we define in here, and then this shortest path I want to calculate for this road network, and which is stored in the G. Okay, just I copy the G, and I already create the node, start node and end node. So just define here start node and end node. So this is my start node. I copy this variable and paste here, and also end node. Just I copy and paste here. Okay, and if you want you can also mention about the weight. Suppose I put here that wait, I put here the it equal to length. Okay, just I put here the length. So now further run the code. Okay, it's okay, there is no problem. Now I want to plot this shortest path. After creating the calculate the shortest path, now I want to create the plot and display this result. So for that, just take the new cell again, and now just create the figure, and I take the variable x and call the ox plot graph root. Okay, graph root, and further I just call here the g and define here the shortest path. Okay, just I define the shortest path, just copy and paste here. Okay, so now run the code and check the result what happened. So we create this type of, okay, suppose this is my start point and this is my end point. So it find out this shortest path. So this is the shortest path or short route between these 2 points we find out. So this map you also create look more better. So for that you can simply identify for node size or also background color. So this type of things you can also add and create the more better map. Suppose in this case I just put the another argument, it's called the root line width. So just I put here root line width. So I define the root line width. Suppose in this case, suppose I put here that 4, and we can also define suppose node size. Suppose I put the node size is that 5. So now run the code. Okay, so we can find out this type of map. If you want, you can also add suppose this type of thing, suppose background color, okay, or node color, okay, or s color. Suppose I simply copy these things and further I want to add in here, then check what happened, is it okay or not. I just put and run the code. So we find out this type of result, but it not look more better because in this case the red is also mixed. Suppose I want to put here that color is a suppose yellow color. Okay, so now it look more better. We can easily identify this is the shortest path between this point from this point. Okay, so this is the way to analyze the shortest route analysis. Further, if you want, you can also calculate the area. Suppose how much area we find out, or measurement the length of the shortest route. So this type of tutorial further I'll also try to upload it. Okay, so in the meantime you can also practice this code, all of details, and further face any problem, then simply comment, then I also give you the answer. In the meantime, I also give you an announcement for our upcoming online training program. Basically it's a total 7 days live training program on Google Earth Engine, and this class will be start from the 24th January. If you are interested to learn the remote sensing analysis using Google Earth Engine, and if you have no knowledge about that JavaScript or Python, or if you have no knowledge about the cloud computing software, don't worry about that. In this online training program you will learn all of things from beginners to advanced level on Google Earth Engine, and further you can easily create the different types of remote sensing analysis. So you can easily get all of information from this video description. You can also visit my website and check all of details. And if you want interest to join this online training program, simply contact in this email or also contact with this WhatsApp number, and you can check all of course content. Okay, so for the different days we try to test different topic, so you also try to check all of topic. And each day we provide total 4 hours training program, 3 hours live training, 1 hours for the problem solving class. And when you join this online training program, you can get some benefits, such as after completing all of assignment, you can get that e-certificate, as well as you can get the all of course material, you can get all of practice code, all of recorded session you also access, and you can also get the lifetime teaching support regarding this online training program. If you face any problem for any content, you can get the support. And we also providing the research collaboration. So regarding this topic, any topic, if you are interested to make the research paper or collaboration research paper, then we also try to help you, and then further we also try to make the or publish the research paper. Okay, so this type of opportunity you can also get for publishing scientific paper or lifetime teaching support, recorded class, and also get the all of practice code, also get all of material, and also get the all of, after completing all of assignment, you also get the course certificate. So if you want to join this live training program on 7 days for Google Earth Engine, it will be start from the 24th January. And we also providing the first 10 days will get the 50% discount on this online training program. To get the 50% discount as soon as possible, complete your registration and then join our upcoming online training program. Today is no more. Thank you for asking that. Stay healthy, stay safe.